this episode, we are going to be focused in the voltage, in the output voltage produced for the generator. This is the voltage regulator. The hot, the neutral, and the ground enter into the voltage regulator, and the voltage regulator regulates the voltage, keep the voltage stable, and this is the output, and those cables enter into the breaker. This is the voltage regulator. If the increment or decrement is more or less 10%, you can adjust with a small screwdriver in the first spot. The first spot is volts. This is to calibrate high voltage or low voltage if the increment is no more than 10%. For example, in this moment, the reading in my voltmeter is 127 volts and 28 volts. It's a little higher. I can adjust, of course, with the engine running. I connect my voltmeter in the terminals of the breaker, and with the generator running with a small screwdriver, flat screwdriver, I adjust the spot volts. What is the meaning of gain? Gain is the time that the generator spends to recover the maximum RPMs. Let me explain something. Normally, when you apply loads on the panel, you hear that the generator decrease the RPM a little and immediately recover the RPMs. That procedure normally takes a couple of milliseconds. You apply the load, the generator decrease the RPMs and immediately recover the RPMs. In some cases, when the load is too heavy, when you apply the load on the breaker, you hear that the RPM decrease and recover, but immediately recover the maximum RPMs. Be careful, because adjust the gain is not related with adjustment of frequency. Frequency is completely different, it's not related with gain. Some people confuse both terms. Gain is the time that the generator requires to recover the maximum RPMs. That's completely different. Once again, in the voltage regulator, we have three spots. One spot to calibrate output voltage, higher or lower, no more than 10%. The second spot, stabilization, is used to calibrate fluctuation in the output voltage. And the third spot is gain, is used to calibrate the time to recover the RPMs. This is a single phase motor. Remember, the single phase motor always use capacitors. The capacitor is used in single phase induction motors, AC motors, to produce an extra voltage at the beginning in order to produce extra torque. This is used normally in single phase motor. In three phase motor, you don't need capacitors. You have the phases in different angles, and the torque produced is excellent in comparison with the single phase. Is only like one piston to move the rotor. In this motor, three phase, you have three different pistons in three different angles. It's easy the movement and the speed of the shaft. The ground to the case of the motor, and the hot to the other. And now this is 0 mega ohms. If the needle goes to this side, this is the maximum, this is infinite, and this is 0. I can check the other phase. Once again, around 20. That's not good. If I check with the analog, with the digital, should be exactly the same. I can use this equipment to check three-phase motor. For example, I am going to check with this digital megometer this three-phase motor. I have the ground here, and I have the phases here. I am going to check the phase number 1. And I am going to show to yours. I can apply 1000 volts, 500, 250, 100. I am going to apply 500 volts, and I am going to apply the test. Some seconds is 543 mega ohms.